There's no fresh air up there.
Okay?
And just because it comes from outside doesn't mean it's fresh.
I know.
So it's outdoor air. I try and avoid the word fresh in any of my reports. It's outdoor air.
Correct.
Whatever is outdoor is what you get inside.
Do we have to filter the air differently in Arizona from the dust and airborne particles?
There are different levels of filtration in filters. You need a 2-inch filter that has a certain amount of efficiency or percent reduction of contaminants. And the higher you get towards HEPA, the more energy pressure drop it takes to get across it.
Correct.
Et cetera, et cetera.
You seem to be right in Dave's wheelhouse here.
That's why I came today.
So most of these pollutants, some could be completely taken care of by passive design, meaning we properly placing and planning these different sources in our planning process. But some we have to rely on dilution. So that's where the ventilation rate comes into play. And for a typical office, outdoor air that we bring in is 20 CFM per person. That includes the, correct me if I'm wrong, that includes the sources.
So this is the old version of it. This is the past, 2004 and beyond, in the back. So our 2006 code still follows the 2004 ASHRAE.
Right.
But now as we get to the 2009 IMCs and IBCs, it'll bring up the 2007 ASHRAE code. And the 2000 ASHRAE got into splitting people in areas.
Separately, right.
Yeah.
So how do we bring fresh air or outdoor air? There, remember we talked about switches?
Yeah.
So there's two ways to bring it, and it goes back to your point as far as bringing in just outdoor air by opening a window. That's manual switches. But then we also can have automated switches, which is what most of our mechanical engineering design does. So the point here is if we are advocating manual switches, meaning opening our windows, then we have to make sure it's somehow treated, or the client is okay with all the pollutants that come with it. So that's a problem. So in general, more outside air, because most likely we will choose the automated switch option, because most clients don't want pollutants. So the more outside air, more energy. This becomes a problem if indoor air quality is of utmost importance to your client. So there is a lead credit to go above and beyond what's minimally required and provide more outdoor air than what's required. And if that's something that your lead project goes after, then we should understand that we're taking a hit on the energy consumption.
I would put a caveat on that, is that is definitely true in the Phoenix area. In other areas of the nation, more outdoor air could be, their outdoor air is very...
Good point. Very good point. Yeah.
Moderate.
Correct.
So it doesn't necessarily, a lot of times the economy...
You don't have a huge hit. Right.
Running just outdoor air through your air handler rather than running the cooling compressor and the heater and stuff. Sometimes the outdoor air is the right temperature that you want.
Correct.
So mechanically moving that around is more energy efficient.
Yep, that's a very good point. Because remember our psychrometric chart that we looked at?
Right.
Natural ventilation here is only 1.4% of the entire year. So it's practically useless.
So in other regions, that might not be true.
Right. So it's good to check that first.
Test it.
Use our climate analysis program. Okay, so we're going to get into the actual HVAC design a little bit. Now I just want to show the psychrometric chart really quick to see why we need HVAC. How many of you think we have to use HVAC in Phoenix?
If you extract your comfort.
But how many of you can tell me how far down we can push sustainable passive strategies without having a need to use
it depends if you're just talking about me or if you're talking about me and my wife.
There's
Well, when
a-
you have a swing in temperature from 55 degrees at night to 85 or 90 during the day, how can you not incorporate that?
That's true.
Mr. Wizard, come with a
People
response.
lived here before HVAC.
Right.
Don't
So
Does swamp coolers fall
So
into
before
that category?
electricity was
let's go to this.
on the patio.
Yeah,
I mean,
let's go to our
cavemen lived
psychrometric chart.
everywhere. They died when
Okay.
they were 30 years old. Quality of life was a lot less.
Well,
Yes.
we didn't have special ed classes like this.
Okay, let's look at our psychrometric chart for Phoenix. Only 11% of the year it's comfortable. 11% of the year the outside air temperature is comfortable, and we've chosen comfort as the ASHRAE's definition of comfort. So, huh? No.
Average for 24 hours.
Yeah, this is 8,760 hours. This is the entire year. So off that, only 971 is comfortable. So sun shading, we looked at that. Take a look at this guy here. It's 11%. That's the comfortable hours using selected strategies. So the moment I add sunshade, it didn't actually make a difference. Because like we talked about before, shading is assumed for the ASHRAE design comfort. So you have to have this shading. Otherwise, you're going to lose this 11% also. So high thermal mass, a little bit high thermal mass with night flush. The reason why there's only a 0.5% increase is because the night doesn't get as cold during the summer days when we want them to. So the night flush doesn't work. But look at this, direct evaporative cooling. But we have the problem with evaporative cooling. What is that?
Add moisture.
Right. If we add moisture, then what's our problem? Fungus and so other problems, right? Okay. Two-stage evaporative cooling. That has a little bit more than direct evaporative cooling because you're not directly exposing or adding moisture to it. Natural ventilation is only 1.4%. So it's, let's say you do that too. And then fan forced ventilation. This is a hybrid that I talked about. The problem with natural ventilation is we don't have enough window here. So if we naturally use, mechanical ventilation to draw air, we can increase that percentage of comfort by 6% more. So that's the hybrid passive. And internal heat gain solves most of our heating needs. Passive solar direct heat gain solves the rest of the heating needs. Wind protection, we don't really have to worry about it here. Humidification, it helps for about 3%. Dehumidification, we don't have to worry about that because we have very dry air. And so, if you look at all this, let's say you do all of these different passive strategies in your building, all of them. Look at this. You're only up to 85%. You still need Dave. So Dave has a job.
Yes.
Hey, Primus,
Yeah.
is a evaporative cooling considered?
This guy, you can do evaporative cooling without air conditioning.
Not right now.
But is it
Is it
considered?
considered?
You are conditioning the air by adding moisture.
Yes.
Cooling,
Yes.
Right.
Correct.
just not compressor.
Correct. Now, we're going to look at that. Not so good. Okay. So I think it's important that right off the bat, given our climate and building type, we should quickly go through this and see how far I can push not having Dave.
My challenge to Prim is working out of a job.
Right. And so that'll give us an understanding that
That's
how far we can
architectural
actually
engineering
do
is
this.
right
Right. But as you may see,
not all of this, you can't do all of the strategies in our buildings.
Passive market.
Take away direct evaporative cooling, take away indirect evaporative cooling, you lost 30 to 40%. So now the 15% HVAC need jumped to 50%. So it depends a lot on what strategies makes more sense for the climate and for the client. So to sum that up, the primary need for why we're designing all these things is to have the thermal comfort, visual comfort, and all the other comfort. Thermal comfort wise, these are the five areas where we perceive comfort: air temperature and surface temperature, air motion, relative humidity, and air quality. And we looked at the different ways we heat transfers: conduction, convection, radiation, whatnot. Heating is primarily through conduction and radiation. So the two criteria that we perceive heating or that governs heating is air temperature and surface temperature. So here in Phoenix, if we have enough solar glazing on the south and enough mass, we could take care of heating needs completely passively. But the problem here in Phoenix is cooling, and cooling is dominated by these three guys: air motion, relative humidity, and air quality. This is not a huge problem in Phoenix. Relative humidity is. Air motion and air quality is the biggest problem. And how would you passively use air motion techniques to solve cooling needs? By having natural ventilation, opening up your windows, and maybe providing some water body in front of the windows and some vegetation to filter the air. So you can do those things to some extent. But as you noticed in the climate chart, you can only stretch that to a certain limit. Beyond that, you need mechanical cooling. Likewise, we looked at a lot of air quality issues. Most of these air quality concerns, we can solve that through proper planning. But sometimes we have to use dilution as a solution. So there's no way that we can avoid HVAC design in the Phoenix climate unless our client's willing to deal with all those different issues that passive technologies come up with. So it's important to balance both the passive and active design in our projects. Does that make sense? Agree? Yes? Okay.